Hello there again. So now let's work in the mesh. So let's do, for those who want to do everything from scratch, reading the original mesh that I'm putting in the website. So just to remind you that in website you will have the meshes there. Okay, so to use those meshes, there is some renaming involved if you want to use also the scripting files. So see that we have this mesh. In this case, you can read any of the both meshes. You have the coarse and the fine mesh. So you will see that the names here, you have been running the cases in boundary. Pretty much they are kind of different from the ones that we need for the cases. So I will show you just how to set up the case and also how to set up the periodic boundary phases. So here you will see that these are the actual names that we need to use, okay, in the mesh. So just to show you the renaming, so we have inlet and outlet. So as you read the mesh, doesn't matter if you have the quartz or fine mesh, they both have the same name. And so we have, see that you select here highlight zone and it will highlight the actual phase. So this one should be named inlet. As you go here, edit, you put inlet, okay, so you rename it. Doesn't matter the type of boundary conditions you use. Then we're going to read the file. Then you have write, that should be that one. So let me call it outlet. Okay, so we have down, that should be, if I would recall, should be bottom. Yes, bottom and top. So we will put it bottom. And then up should be top, and then front and back, those two are okay. So front and back and cylinder. So you have front, back, and square. So we renamed. So this is, you see, as easy as that. You just edit and then you just rename there, and now we have the right naming for the patches. So the next step now will be to create the periodic boundary conditions. So the periodics, as I mentioned previously, is just consisting in having a master and a slash or shadow phase, and then whatever is going on here, it is entering here, and vice versa. So to create those, you need to access that information from the text user interface. So let's go here, and if I will recall, we should go to mesh, and in mesh you will have somewhere, let me see if I recall, modify sums, okay, and there you see make periodic. So what is important, that you need to give an ID to the patches that you want to make periodic. So as you go here, as you press back, see that you have ID, have a number 14. You have front, you have an ID 15. You need to know these two IDs to give when you create the periodic phase. So I go make periodic, and it will ask you the periodic zone. So I want 14, and the shadow zone will be 15. So basically, we'll ask you for the two surface boundary surfaces that you want to make periodic 15. Then what kind of periodicity do you want? You have translational and rotational. So I want translationally, so I will put here no, and yes to create periodic. Yes to auto detect, because you have a distance there, so you can give it manually or you can make it to detect automatically. You just put yes and will detect it automatically. And see that it created, it found the distance. So as you check your dimensions, you will see that it's right. Refresh, and as you go back here into boundary phases, you see that now you have periodic. So in theory, one patch is disappearing. In this case, it's from, but it's because you have those two phases collapsing one. So see that highlight, you are collapsing two patches, two surface boundaries into one single boundary, which is the periodic one. Remember that periodic requires boundary conditions. So as you go here, periodic conditions, you can give pressure gradient or mass flow. So in this case, you don't need to give any of that, so it doesn't matter. But if you give pressure gradient, for instance, you put a value of 1, then you need tell the direction, so it can be in this direction, for instance, can be from here to here. So is the flow coming from here to here? You have that constant pressure gradient. Okay, so in this case 0 is 1, you can put it here 1. 0, 0, 1 means that it goes in this direction, so it doesn't have any influence, but it doesn't matter, okay, in this case. So they, okay, now put 1, 0, just to give where you want the mass flow or the pressure gradient, that's all, but it's not important in this case. So we define the periodic boundary conditions, okay, and at this point we can define the whole case. So remember also it's always recommended to check the scaling dimensions. So see that we have all dimensions there. Check your mesh quality, evaluate everything. Perfect. So in this case we can go through the setup. So we know that you can go in general, steady, unsteady, turbulence model, boundary conditions, everything. But remember that we can use the setting files. So let me go to those files. Okay, so if I open here, when you download the cases, you will have all that information available. So you have here settings, and I would use, for instance, the settings for the run simulation, just to take one. Okay, doesn't matter. I put it here in meshes. I'm working here. Let me put it here. And when you go back in Fluent, you will go here, Q, and then File, Settings. Okay, first you need to have the file in the working directory. So to know the working directory, you type pwd, and it will tell you that you're working in this directory. See that here you put your settings files. You go read settings, and then it was settings runs, and see that it read the settings file. There are a few errors where it doesn't matter, but then you can correct whatever you have. Okay, so general, steady, see that set up everything. Materials, it set up the water liquid with the properties that we're using. Okay, then in cell zone we're using that material there. Then you go to boundary conditions and see that, for instance, velocity inlet, you have the right values, you have everything is automatically set up with those files. Reference values also, they are set up the right values. Methods, then report definition, you have all your report definition, all your monitors. Okay, so this is how to set up automatically the case. So you can go like this, do this renaming, start from scratch, run the steady simulation. Okay, let's do it. So you will see compute from inlet. So now let me go and do the full multi-grid initialization. I will go solve init fng, yes, and it will do the initialization, the quartz mesh. I will run, I will get an initial some solution. I will do all my post-processing, mesh quality and everything. So remember also here in custom fields, you have these two fields automatically computed also with the setting files. Okay, and now I can run using the method, the couple method. So let's run and see what we get, just to show you the whole workflow. So this is a relatively fast, steady computation. Okay, so let's wait a little bit. Okay, we're back. See that in my case here, it converts in about 54 iterations, really fast. The coupled solver, we know that the simple will have different behavior, and then you can start and plot and do all the post-processing that we have done so far. You can do it. Okay, compute the integral length scales, plot velocity, whatever you want. And then also save your interpolation files, and then you interpolate this one in the steady cases and keep going. Okay, so at this point we are almost ready to start the list simulation. Okay, so if you have a solution, let me write the data, select your data, you give it a name. Okay, so I will call it intercouple. Just save it, have the data, and this data now you interpolate it into your setup for the less simulation, and you are ready to go. At this point we'll be waiting a little bit. So the next tutorial, now we're going to officially move into the scale resolving simulations. First less, then this, and we are done with the whole lectures. Okay, hope you enjoy it. See you next time. Bye.